Hey guys, Adam here with another Punch-Out repair, and this one comes to us from Dave from Buffalo. I normally don't show the box, but this cracked me up. As you know, the Punch-Out board set is probably about yay big. Yay thick. It's got three boards kind of laid on top of each other. And Dave was very worried about getting it here in a safe manner, and so he threw it in this massive Home Depot box, and I caught this note, so I just had to share this. This is pretty funny. It says, "Hey Adam, here is my Punch-Out PCB. Sorry I went crazy with the peanuts. Thanks again, Dave." So this is like, I don't know, 1.5 foot worth of packing peanuts, and I'm sure somewhere in here is a PCB. My gosh, Dave. So he had asked me, like, how should I pack this thing to send it to you safely? I said, well, what people usually do is they just wrap it in bubble wrap and put it in a box and then surround it with packing peanuts or even crushed up paper or whatever. And he took that literally. But hey, it got here safe and sound, obviously, because it's, you know, there's no way you could damage this thing. So I have no idea what the condition of this is. I'm about to throw it on the bench, so why don't we go ahead and do that, and we'll see where we are at. So here's the board on the bench. Let's fire it up and see where we're at. Alright, a little bit of wiggliness there. Let me switch over to the other monitor. Okay, some crap up there. So I believe this one, what is this? I think this is the lower monitor. Yeah, there's all sorts of weirdness going on. Sync issues. Okay, so it looks like the upper monitor, for the most part, is in pretty good shape, aside from the sync. And as I'm messing with these cables here, the sync seems to be getting a little bit better. I don't know, maybe sporadically. But anyway, that's the upper monitor. You can kind of see the image there. The image itself is pretty decent, but that's obviously got issues. So you can kind of see Glass Joe there with your player character. The colors are completely off in the player character. The background's gone, and other crazy stuff. So why don't we start by getting our sync squared away here, because how are we going to debug this if we can't really make out the picture? So we will start with the sync and we'll go from there. Sync, I believe, is generated on, boy, it's been a while. I think it's the middle PCB, and then it gets broadcast to both the upper and the lower monitor. So let's start there and see if we can clean this up. So I threw my cables on here, obviously, because I'm going to be testing it out, and that actually cleaned up the sync issues. So I suspect that these guys just need to be cleaned out a little bit or something. Alright, so here's what I'm seeing. So this is the lower monitor. Upper monitor is fine. This garbage here is what gets displayed by the back PCB. This guy right here displays the background, you know, the ring with the audience and all that kind of stuff. I don't really see it doing anything. In fact, I think this is pretty much random. If I turn the game off and then turn it back on, there's a particular pattern, but if I keep doing that, the pattern is random. And so I suspect that, I don't know, maybe I could be missing a clock somewhere, I don't know, or the information from the CPU PCB is not able to get written into here, because this guy, the CPU PCB, decides what gets written to the screen, and it writes that information through these edge connectors here into the RAM, and then that gets driven out to the ROM to pick out the actual little tiles that you want to display, the ring and the audience and all that kind of stuff, and then it ends up on the screen. If that stuff is not getting into the RAM and you just boot it on, whatever garbage is in the RAM is what gets shown up on the screen, and I think that's what we're seeing here. So my guess is that the CPU is not able to, CPU PCB rather, is not able to talk to the back PCB. So that's one issue. The other issue, of course, is this guy down here. I think it actually, the CPU PCB is able to talk to the video PCB, and it's drawing, or it's trying to draw the your player here. But I think there might be an issue from the video RAM to the video ROMs on the video PCB, just for the player though. And so the location here you can see is correct. The player is in the right spot and he's moving from side to side, and that's really dictated by the video RAM, the address into the video RAM. So I think that's okay. But that information then gets thrown out to the sprite ROMs themselves, and that's what dictates what actual sprite gets drawn in each location. So you can see the position is okay, but the sprites themselves for the player is completely off. So there might be something in that path from the video RAM to the sprite ROM. We'll check that out later. First, I'd like to clean up the background here. So luckily it's right here, it's exposed, I can get to it. I'm going to grab my logic probe and start poking around at certain key areas to figure out why the CPU PCB can't talk to this guy. So I did some poking around, nothing suspicious yet. For the most part, you know, the back PCB looks pretty solid. I think what I'm going to do now is hook up the Fluke to it, and because what I'd like to do is, these are the RAMs right here, these three guys. They're actually shown right here. These are the little video RAMs that are on the back PCB. What I usually do in a situation like this is, you know, I start at one end and I work my way over. So what I'd like to do is fill these RAMs with a known value, say all zeros or all ones or something like that. Some kind of a deterministic pattern. And that way I can take my logic probe and then start probing these guys to see if anything's messed up. So for example, if I fill these guys with all zeros and I start poking with my logic probe and I see 0, 0, 0 and all of a sudden 1, well then I know it's an issue with the RAM. If they're all zeros and everything's fine, I'll try maybe another pattern, a bunch of different patterns, and everything seems fine from this point on, well then I just follow it on to the next guy, which would be the ROMs here, and see is there something wrong with the ROMs, are they not getting access correctly and whatnot. So that's the next part. I'll go ahead and throw the Fluke on, and then we'll go from there. Well, as you can see, we had to throw on the logic analyzer here to see what was going on. So I actually did start by looking at that RAM here. I flooded it with a bunch of ones, and I actually saw some zeros trickling out the other end. So that told me that either ones on the data path weren't getting written into here, or maybe the addressing was screwed up, and so it was starting to fill it with ones, and then it skipped over a couple of entries, and then continued to fill with ones, and those entries that didn't get written to, whatever garbage was in there, was getting read out. And so it caused me to kind of take a look at the addressing a little bit. So this address comes all the way up and is driven by the CPU PCB through these buffers here. And so what I decided to do is take a look at what is getting sent in and compare it to what is getting sent out. And what I found was something interesting. And so here is, let me see if I can zoom in. So this is what's getting sent in, DMA, and address is what is getting sent out. And so if everything is working properly, these should match. So you can see that they do, 0 and 0, 1 and 1, but all of a sudden there's 2 and 0, and then 3 and 1. And then we're okay for a little bit. 4 and 4, 5 and 5, and then again 6 to 4, 7 to 5. So what's going on there? Well, if we look at binary, let's see, so the one that's getting screwed up here is 2 and 3. So let's start with that. So binary 2 is 0, 0, 1, 0. If this bit right here is forced low all the time, then this will become 0, 0, 0, 0. Alright, so our 2 is getting changed to a 0. And then similarly for 3, that's a binary 3. If this bit is getting screwed up and forced to 0, it'll become 0, 0, 0, 1. And that's exactly what we're seeing here. Basically every value is 2 off, right? 2 subtract 2 is 0, 3 subtract 2 is 1. These guys are okay, and the reason they're okay is because the binary value for 4 is 0, 1, 0, 0. This bit here, the one that's getting forced to 0, it's already a 0. So you don't see the effects of that being forced to 0. It doesn't do anything to the value. And then similarly for 5, 0, 1, 0, 1 is 5. It doesn't matter that that's getting forced to 0 because it's already a 0 when you're looking at 4 or 5. But then when you look at 6 and 7, the pattern repeats, right? Right here. 6 minus 2 is 4, 7 minus 2 is 5, so on and so forth. So what does that mean? Well, it means that that bit, whichever guy this is, on this buffer is screwed up. It's always driving a 0 regardless of what's on this side. And so I think these are what, 74 LS 367? They should have a few of those kicking around. So I'm going to pull this guy right here, and then hopefully we'll get that signal working properly again. Okay, got our new buffer installed right there. Let's fire up, crossing our fingers here. Oh, hold on. Hold on, hold on. No. Alright, that looks better. Let that play through a little bit. So hopefully this should take care of all of the background and alphanumeric issues. Yes, beautiful. and we'll just let it play through here. I suspect everything should be good now, with the exception of the player sprites, because that logic is all on the middle PCB, the video PCB, and I haven't even touched that yet, so I suspect there's still issues there. Glass Joe, and yep, okay, cool. So now we need to just start looking at the video PCB, and like I said earlier, the positioning looks pretty good. You know, he's moving where he needs to be moving and everything. But the color's off, and the sprites themselves. There's a lot of small sprites that are kind of stacked up next to each other to make the entire player, because obviously it's just too much data to hold as one sprite. Most of these little sprites are like 8-bit by 8-bit tiles that they kind of put together like a puzzle, basically, to create your characters. And so yeah, so I think just by looking at this, it's probably somewhere in the data path between the video RAM and the ROMs that hold this particular sprite information, and that is on the video PCB. Do I have that schematic? I do have that schematic. So this whole, you guys have probably seen me do this 100 times. This whole upper half is for the opponents, and this is for you, the character here. And so, taking a quick glance, these are the sprite ROMs, and I believe this guy here, the 6116, is the RAM. And so the information gets loaded up into here, and then it gets sent out into the ROMs, and the actual data that gets blitted to the screen comes down to these serializers and then works its way over to the screen. So I'm guessing it's right in this area here, which is nice because there's only a couple ICs that I need to be probing. And it could very well be what we saw earlier, where a single bit is high or low, and that could cause all this, exactly what we're seeing actually. Instead of the hair and the body parts where they need to be, it's the incorrect hair and the incorrect body parts all kind of stacked together to make a mess of what we're seeing there. So I'm going to start around here. I'll be poking around for some stuck bits, and then hopefully we'll find something. I might have shown this to you guys before, I don't recall, but anyway. So I'm going to flood this RAM here with a known value, in this case zeros, so that way I can kind of troubleshoot this area. So I wrote a little fancy script for the Fluke that lets me do that. I actually wrote it over on the Fluke IDE on my laptop way over there, and then it runs to a cable over to this guy, so I can write scripts over there and then send them over to the Fluke over here. So if I say execute my little program here, block write program, give me a start address. So here's my cheat sheet that gives me all the address mapping breakdown for the ROM and the RAM. And you can see here I say video RAM for the info screen, that's the upper monitor, video RAM for the opponent, video RAM for the player, and then some background stuff. So just to be sure, let's blow away both the opponent and the player. We'll just write all that with zeros, and what that'll do is it'll take the RAM that's on the video PCB and it'll just fill it all with zeros. I know that I'm only working with this smaller RAM over here, but there are areas where, especially where the data comes in, where it splits into two and then goes to either the lower half or the upper half. Might as well just write it all to zeros to just remove one more variable, and we can make this a little bit easier for ourselves. So anyway, long story short, our start address, we'll start at the opponent is E000, E000, and then it ends at, let's see, EFFF, EFFF. What value do I want to write? 0. Writing data. So right now it's starting in the the opponent region of memory, and it's just filling it with zeros. It's just going to fill all that RAM with zeros, and then the player RAM fill everything with zeros, and then once it's done, it'll let me know. I think what you'll find is as it's writing, this is kind of cute to see, but right now it's starting to write up in here, which you don't really see anything, but eventually it'll get to like the Glass Joe's head. It'll start erasing him, kind of like Back to the Future there, where Marty starts to disappear. There you go, you can kind of see it now. So it's working its way over, it's going to come over here, and you can see it's kind of erasing, which I thought was kind of cool to see. So anyway, fun stuff to watch. We'll let this erase Glass Joe and the player sprite, and then once we're all set to go, we can start probing on that middle PCB. Okay, so these guys are gone, and if I start probing my RAM here and I start looking at the outputs, I believe they start at pin 9. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see that they're low. 9, 10, 11, that's ground. Da, 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 da. So they're all 0, so that's good. Now the other thing I want to check is, it's because let's say one of these is being pulled low all the time. Well, this little simple test that I'm doing is not going to detect that. What I want to do now is do the same thing, flood all the RAM with all ones, and then I can probe again and see if any one of these guys is pulled low all the time. Well, I did all sorts of testing on the RAM, and to be honest with you, it looks fine. I mean, I have the logic analyzer on here, I did a bunch of stuff, and it looks fine. So actually I ran it through again and kind of froze it on this screen and just studied it visually. And here's what I noticed. If you notice here, let me get out of my chair here and move up. You can see the roundness of his hair, but it's kind of in the wrong direction. It's actually mirrored. And similarly for this side, and also you can see down here where his arms form, here and here, they really should be flipped. And then it dawned on me as I'm scanning, you know, every single tile here. So remember, these are 8-bit by 8-bit tiles, and we use a whole bunch of them to make a larger image. Each one of those is actually flipped in the wrong direction. And so that made me think that it actually might be something in this area. So what happens is, and actually every arcade game is like this, it allows you to send the sprites out to the screen normal, but also inverted. And an easy way to think about it is like, you know, Pac-Man, right? If he's moving in one direction, you know, he looks like this, and if he's moving the other direction, he looks like this. And the sprite is actually the same, it's just the pixels are sent to the screen in reverse order. And that's all handled by this serializer logic here. So there's actually a direction, I think it's these two bits down here that control the direction that the bits get sent to the screen. So you can see it gets a whole byte from the ROM, and then depending on these bits, you can either send, you know, bit 0 all the way to bit 7, or you can start with bit 7 and then work your way down to bit 0. So now I'm thinking it actually might be something in this area over here. Now that doesn't explain the reason why the color is off, so I'll have to take a look at that later. But man, just by looking at this now, I can kind of see if I were to take every single one of these columns and flip them, I'm pretty sure that this character would line up nicely. So let me poke into this a little bit, and I wouldn't be surprised if that's what's causing the weirdness going on with our player sprites. Right, so just a little bit more digging here. The control signals to that serializer actually come from this set of muxes, and the select to that set of muxes comes from this little XOR gate, and you can see here H flip and H reverse. So flip will flip the sprite in this direction, and reverse will flip it in this direction, okay? And those are pins 9 and 10 respectively. So if I check those pins, grab my logic probe here, 9P, and you can see I've already been probing here. So this pin here will let us know if we want to flip it vertically, and it's toggling up and down, which is okay. That means there's signs of life there. But this guy right here, this pin, is tied high all the time, which means we always want to reverse our sprites, and that's what the problem is, I believe. So I'm going to trace that guy back and figure out what's going on. And just for kicks here, you can see if so here's our screen right now. You can see, and if I force this guy to be a 0, this is hard to do with one hand. Hold on one second here. Ugh. And now we have our player back. So let me trace that guy back. I'm sure there's something that's screwing it up. Actually, let's just do it. Is it easy to do it here? No, because it gets muxed in with a bunch of, or added into a bunch of other signals here to make the schematic a little bit cleaner. So anyway, I'll go figure that out, and then I'll just update you guys when I figure out what's going on. Alright, so I found it. It's right here. Actually, it's sitting next to the RAM itself. So there's a few registers here, because every entry or every couple of entries in this RAM are coupled together. And there's a bunch of fields. One is the sprite itself, the address to the sprite ROM. And then you've got some other things like what color you want that sprite to be, because you can pick a different color bank. And then whether you want the sprite to be flipped in either the vertical or horizontal direction. And so as that data is pouring out, it's getting latched several times. This guy here is the address for the sprite ROMs. But this guy right here captures the color information, and I don't know if you can see it because my camera sucks, horizontal reverse right there. So so again, this guy is capturing not only what color you want to choose, but also whether or not it should be flipped in the horizontal direction, both of which are screwed up as we saw on the screen. So I'm betting it's actually just this guy right here, which would be nice. Replace one guy and take care of both the color and the flipping issue. So this is what, an LS377. Hopefully I have some of those on hand. But let's pull this guy out and see if we get both the color and the player sprite back. Alright, got our new 377 in there. And we got our player back. And he's looking good. So the sprites are where they need to be and they're the right color. So awesome. So this is kind of still in like debug mode. I got the big cables laid out and everything. I got the fluke hooked up. So why don't I undo all that garbage, put the original Z80 back in, we'll boot it up, make sure we got all of our sounds, and then we'll do a final test. Okay, so back to normal. Got the native cables on here and everything. Let's fire it up and turn the volume up so we can hear it. There we go. Beautiful. So let me coin it up now. Let's see, should be that, and then that right there. And we'll give it a few seconds to count down and see if we have some speech here. Alright, so I'll flip it over. Beautiful. Awesome. So sound is working, video is working. Check the upper screen here. Upper screen, lower screen. Beautiful. So yeah, I think we did pretty well with this one. Had some issues on the back PCB with the background. Took care of all that. Let's see, the player sprites were messed up on the video PCB. Took care of that. And thankfully, there were no issues on the CPU PCB, which is great. Lots of times I see battery acid damage in this area and it ends up creeping into the connectors. And that's a real pain to clean up, but thankfully this guy has been rock solid, so awesome. So yeah, I think this guy is a success. And so thanks again for all your kind comments and the likes and the subscribes and all that good stuff. And if you guys like this stuff, if you like seeing me go through the process of troubleshooting and fixing these games, by all means subscribe. And when I get boards to repair, I'll try to video them and throw them out there as I usually do. So I think that's it for this one, guys. Thanks a lot for everything. God bless, and we'll catch you on the next one.